In this lesson, we will learn about geometric prisms. A prism is a three-dimensional closed surface. It has two parallel faces that we call bases, and those bases are congruent polygons. The polygons can be squares, rectangles, parallelograms, triangles, pentagons, hexagons, or any other named polygon. The other faces of a prism are rectangles. In example 1, figure A is a rectangular prism. A rectangular prism has two bases that are rectangles. The other faces are called lateral faces, and there are four of those. And a rectangular prism has four lateral edges. A lateral edge is an edge of a prism where the lateral faces intersect. Example B is a triangular prism. A triangular prism has two bases that are triangles. There are three lateral faces that are rectangles. And there are three lateral edges. And one thing to remember about a lateral edge is that a lateral edge of a prism is the height of the prism. It is the measured distance between the two parallel bases. Now let's learn some definitions of some useful terms. The first term, which is not on the screen, is surface area. Surface area is simply the area of the faces of a prism. How much wrapping paper would be needed to cover the outside of the prism? And it's found by finding the sum of all the areas of the bases and the faces. There are two types of areas that we are often interested in. The first is lateral area. Lateral area is simply the sum of the areas of the lateral faces only, and that does not include the bases. As you can see in the sketch of the net of a rectangular prism, we're interested only in the areas of the four lateral faces. The total area, however, is the sum of the area of all the faces, the lateral faces and the bases, as seen in the net. We want the area of each one of the rectangular faces of the prism and add those areas together. Then there's the volume. The volume is the amount of space that is enclosed within the interior of the three-dimensional object. It measures how many cubes of a certain size would fill the prism. And we use the formula to find the volume as area of a base times the height of the prism. The area of the base usually has its own formula because it's the formula for the area of some polygon, and then we multiply that area times the height of the prism, which is really the height or the length of a lateral edge. And another way of thinking of that is it's the distance between the two bases. And in the formula, we usually use a capital B to represent the area of a base, and a small letter h to represent the height of the prism, the distance between the two bases, or the length of a lateral edge. Now let's apply these formulas that we've just discussed for finding the lateral area of a prism, the total area of a prism, and the volume of a prism. In example 2, we have a rectangular prism. It has the dimensions, a length of 8, a width of 6, and a height of 2. We'll name that a rectangular prism. And now we want to find the lateral area. We're only interested in the lateral faces of the prism, not the bases. Now the bases of this prism have the dimensions of 8 and 6. We will not use that information for the lateral area. We will use it later when we want to find the total area. So let's look at the lateral area. It will be 6 times 2 to give the area of one of those bases, or one of those faces. But there's 2 faces that have those same dimensions, so we'll multiply by 2. And we'll add to that the areas of the other 2 faces, which have dimensions of 8 and 2. So 8 times 2, but since there's 2 faces with those dimensions, we'll multiply again by 2. And then we will do the calculation, and we see that 6 times 2 times 2 is 24, and 8 times 2 times 2 is 32, so 24 plus 32 is equal to 56. So the lateral area of this rectangular prism is 56 square units. We use the letter U to represent units of any kind. The units could be inches, they could be centimeters, they could be yards or feet or miles. It makes no difference. Whatever the units are, it would be 56 of those square units. Now for total area, we will include the areas of the 2 bases. So the total area will be the lateral area plus the area of the 2 bases. Well, we already know the lateral area, so now we just need to calculate the area of a base. And the bases have dimensions of 6 and 8. So the area of one base is 8 times 6, which is equal to 48. So now we can calculate the total surface area. Since the lateral area is 56, and the area of one base is 48, and there are 2 bases, we'll multiply 48 times 2. So now the total area will be 56 plus 96, which is equal to 152. And so the total surface area is 152 square units. Now we'll use the formula for volume. The formula for volume is base times height. Well, we have calculated the area of one of the bases is 48. Then we'll just multiply that area times 2, which is the height of the box or the prism. And so the volume is 96 units cubed. Because now instead of measuring the number of squares that fills in a flat area, we're measuring the number of cubes that will fill the prism, and that would require 96. In example 3, we're asked to find the lateral area, the total area, and the volume of a cube in which each edge is 5 centimeters. So let's find the lateral area. The lateral area, again, is the sum of the lateral face areas of the lateral faces. And there's 4 of those lateral faces. And those faces each have dimensions of 5 and 5. So the lateral area will take the area of one face, 5 times 5, and since there's 4 of those, we'll multiply that by 4. So the lateral area of this cube is 25 times 4, which is equal to 100. So the lateral area is 100 square units. Now to find the total area, we will use that lateral area and add to it the areas of the 2 bases. But since all the faces have the same area, there are 6 faces in this cube with an area of 25 square units each. So in this case, the total area is 25 times 6, or 150 square units. And then finally, to find the volume, we'll still use the formula base times height. We've already known that the area of one of the bases is 5 times 5, which is 25, and the height is 5. So we'll multiply 25 times 5, so that the volume is 125 units squared.